Okay, so in example 2, what we're going to do is combine all the rules for the last couple of days all into one pretty big question. So you see that what I have here is a function that is actually the product of two functions. So we're going to use the product rule combined with today's rule to be able to do this. So the question says find the value of f prime at x for the given function at x equals -2. So we're going to look at the whole function and try and analyze it. So the first thing I'm going to look and notice that this is indeed a product. So I've got this function times this function. So even though those functions are a little more complicated than the ones we've done before, it's still the same as yesterday's work. So that means I have to take the derivative of the first times the second plus the derivative of the second times the first. So let's watch. I know you have all the answers in front of you there, but it's worth hearing the explanation, so make sure we're following along. So I go off and I have to find the derivative of the first. Now, when I do that, I notice that that is a question just like today. If you look at it, in fact, it's the same as this question right here. And so I have to use today's rules when I'm actually doing the derivative of the first. Today's rule says I do the derivative of the outside first. So I've got a 4 to the power of something to the power of 3. That something is 7x minus 2. I just do it as is. Then I have to differentiate the inside, which is 7. And all of that is simply the first step in the product rule, derivative of the first. Now it's times the second, and the second is written as is. So there's the derivative of the first right here times the second right here. Plus the second half is the derivative of the second times the first. So I have to do the derivative of the second, this guy. Again, I notice it's another power of a function rule. So it's being raised to the power of 5, so it's 5 something to the power of 4. That inside stays the same. Then I have to differentiate inside, and the derivative of the inside is just 2. That's all the derivative of the second times the first. Oops, times the first, and the first is as is. So 7x minus 2 to the power of 4. And I want you to notice then, even though that's a big long statement, it's all the power rule. So this here is the derivative of the first. There's the first times the second, as is. This is the derivative of the second, all this, times the first, as is. So we've used the product rule inside the, or the product rule on the outside, and inside we had to use the power of the function, or today's rule. So the trick in these is really just being able to practice them and being able to organize your thoughts and all the work that's going on. So you know that this is, you first got to do that product rule, so you look on the outside and then look on the inside. And that's what we have going on here. Now the rest of this is really just simplifying a little bit. So I see that I've got a 4 times a 7 times this, but this has an exponent 5, so I'm going to ignore that part. I can't really simplify that. I just got the 4 times the 7, and I got 28 7x minus 2 to the power of 3, and this is just as is to the power of 5. Those both have exponents. I can't do any better than that. On the second half, I do have a 5 and a times 2, so that can be at least simplified to 10, and this one has an exponent I can't simplify, and the other one does too. So we've made our life a little bit easier, and this is what we would write if I asked for just the derivative. So the derivative is just this, and we'd be done. That's pretty much as far as we could simplify it. But this question does go a step further. It says, I want you to find the value at x equals -2. So I want you to sub in -2 into this function, or the derivative, excuse me. So it's f prime at -2. So wherever we see an x, we're going to replace it with a -2. So it's 7 times x, so it's 7 times -2 minus 2, all cubed. 2 times -2 plus 3, all to the power of 5. The 10, so it's 2 times -2 plus 3, all raised to the power of 4. and 7 times negative 2 minus 2, all raised to the power 4. And I know the rest of it you have in front of you, but I'll quickly finish off. So it's 28. This is 7 times negative 2 is negative 14, minus 2 is negative 16, raised to the power of 3. Negative 2 times 2 is negative 4, plus 3 is negative 1 to the power of 5, plus 10. This is negative 1 to the power of 4, and that's negative 16 to the power of 4. This is going to result in a couple of big numbers here, but we can handle that. Negative 16 to the power of 3 off the top of my head is negative 4,096. Negative 1 to the power of 5 is going to stay negative because it's raised to the power of 5. Negative 1 to the power of 4, however, is going to be positive 1. And negative 16 is going to the power of 4 is also going to be a positive, and I believe it's about 65,536 if I remember my 16 times tables correctly. Multiplying here, I got a negative times a negative is a positive, times the 28 is going to be 114,688 plus 65,536. Add them together, and we get a whopping 770,048. So what we actually found was the slope of the tangent at x equals negative 2, and apparently it's pretty steep. Definitely something I wouldn't want to graph and try and calculate the rise of 770,000 over 1. So the key, of course, is being able to organize your thoughts, keep it all organized as you're taking the derivative. So using the product rule and the product of a function, power of a function rule today, being able to keep it all organized is the key, and that all comes from practice. So the practice I'd like you to try is page 145, number 2 and 4 e to h, and you'll have the rest of the period to try that.